Hey y'all, today we're going to be talking about solving systems of linear equations by graphing. So a system of linear equations is when we have more than one linear equation, so two, and we need to find where they intersect, because if we have the right lines, then they're going to cross each other at least once. Okay, so to actually solve them by graphing, the first thing I need to do is I need to be able to graph them. And to be able to graph these functions, we need to make sure that they are in slope-intercept form. And in case you forgot what slope-intercept form, that is just our y equals mx plus b. And the reason why we need this is because we use slope when we use the y-intercept to graph. Okay. So the first thing we're going to check, we're going to work kind of as we fill out our steps for solving by graphing, we're going to work through example 1 at the same time. So on example 1, we have y is equal to negative 2x plus 3, and we have y is equal to 1/2 x minus 2. So both of these functions are in slope-intercept form, so we're good to go on step 1, sorry. Step 2, once we have them both in slope-intercept form, we can go ahead and graph both of our lines on the coordinate grid using your slope and y-intercept. So for each of these, I'm going to graph them on these coordinate grids. So y equals negative 2x plus 3. My slope is equal to negative 2. And remember, anytime it's a whole number, we want to take our slope and make it that number over 1. And then our y-intercept of b, which is 3. So first things first, when graphing a linear equation, just in case you forgot, we do y-intercept first. So my y-intercept is 3. So I'm going to put a point at 3 on the y-axis. Second step, we graph the slope. So my slope is negative 2 over 1. It's rise over run. So that means I go down 2 and over 1 to get my next point. And if I wanted to make it a little easier to graph, which is going to be very important with these, that you graph nice straight lines, I can keep repeating the process of down 2 over 1, down 2 over 1, down 2 over 1, and so on all the way down to get some more points. Make my job a little easier. So once you feel like you have enough points, you can come over to your line tool. And insert that line into your graph. Add your arrows onto the end of your line to denote that it's continuous, and we're good. That's one graph down. Okay, so we have to graph both lines, so now we have to do the second one. So y equals 1/2 x minus 2. My m is equal to 1/2. And my b is equal to negative 2. Okay, so b first. So I put a point at negative 2 on the y-axis. And then slope is 1 over 2. So we're going to rise by 1 and go to the right by 2. Up 1, right by 2. And then I can keep repeating if I want to get some more points. And of course, you can also go the opposite direction to get more points the other way as well. And then once you feel like you got enough, you can add in that line. And of course, add in your arrows. Okay, so some things you should notice. We have two lines on the graph now, and if we did everything right, we should have a spot where those two lines cross. So we actually call this the point of intersection. So step 3, we're going to find the point of intersection. So the point of intersection is where they cross. And if we look closely, we can see that they very clearly cross right here at an x value of 2 and a y value of -1. So as our very final step, we want to write the point as an ordered pair. And just as a reminder, an ordered pair just means x comma y with our parentheses. So we just talked about this one. So our answer was 2 in the x direction, -1 in the y direction. So 2 comma -1 would be our point of intersection. And we're done. That is how you solve a system of equations, of linear equations, by graphing. You graph the two lines, find where they intersect, write that intersection point as an ordered pair. Okay, let's look at some more examples. So number 2, we have y is equal to -3x plus 6 and x is equal to 3. So our first one is easy. So let's graph that one first. So y is equal to -3x plus 6. Our m is equal to -3, and then go ahead and move it to over 1. And our b is equal to 6. So on our graph, y-intercept is 6, so I'm going to put a point there. And then my slope is -3 over 1, so I'm going to go down by 3 and to the right by 1. Down 3 to the right by 1. Remember, we always go to the right. The negative is just going to tell us if we go up or down with our rise. Oop. That points in no man's land. And then we add in all of our stuff, our line, our arrows on the end, and we're good with line 1. Okay, our second line is x is equal to 3. So that doesn't look like slope-intercept form, but it's actually a much simpler line. If you remember, anytime we have y equals or x equals, it's a horizontal or vertical line. X equals 3. Well, that means it has to go through the x point 3. So for me to draw a straight line through the x value of 3, it has to be a vertical line. So I put a point here at 3. And then I'm just drawing a perfectly straight vertical line through the x point of 3. And as always, y'all, if you don't draw it perfect, you can always go in and just move it a bit. Ooh, too much. And then we just go in and add our, once again, arrows onto the end, because even our vertical line continues forever. All right, now last step, find that point of intersection. Okay, now this one can be kind of hard, so that's why it's nice and cammy that you can zoom in. Our point of intersection is actually right here. So that's why it's really important that you draw nice, clear lines. Point of intersections, especially when I give you ones that should be solved by graphing, are typically going to be nice whole numbers. So don't get too confused and be like, oh, I think it might be like -2.8. Okay, they should be nice whole numbers. So don't get too thrown off by that. But the straighter and better you draw your lines, the easier it's going to be to see your point of intersection. Okay, so that point is 3, -3. So we just write that as an ordered pair. And then we are good to go. Okay, so far so good. Example 3, we have y is equal to x plus 3 and 2x minus 2y is equal to -6. Okay, so this one we have a little extra step because we've kind of been skipping it, step 1, which is make sure both equations are in slope-intercept form. Well, all of ours have been so far, but this one we finally have one that is not. 2x minus 2y is equal to -6. So I got to solve this for y first. So I want to get y by itself. First thing I can move is my 2x. So I move positive 2x by subtracting 2x. A couple reminders here. remember, we do not subtract the negative 6 and the negative 2x because they are two different types of terms. So negative 2y is equal to negative 6 minus 2x. Then that negative 2 multiplied in front of y, I can divide it with everything. So 2 and negative cancels out, 2 and negative cancels out, negative 2 goes into 6 3 times. So we get y is equal to 3 plus x. And just to make it a little easier, y is equal to x plus 3. Remember, we can always switch those two terms because of the associative property in addition. Okay, so from here, I can do the same things that we've been doing. So my first line, y is equal to x plus 3. It's in slope intercept. My slope would be 1, because anytime we don't see a number written, it is 1. And we can also write that over 1, so 1 over 1. Our y-intercept is equal to 3. So down here, point at 3. And then our slope is 1 over 1, so we rise by 1, run by 1. Rise, run. And hopefully you should start to kind of see the pattern and you can kind of go a little quicker from there. Add in your line. And then we are good. That's our first line, y is equal to x plus 3. Okay, our second line, what you probably already picked up and you're like, Mr. Arbone, what's going on, is also y is equal to x plus 3. So let's just go ahead and graph it. It's going to be the same thing. Slope is equal to 1 over 1. B value is equal to 3. So should be the exact same point, essentially. And there we go. All right, so what you've probably picked up on is because both of our lines are literally exactly the same, we touch them everywhere, okay? We don't have one point of intersection. Our two graphs intersect their entire line, okay? So instead of having just one solution, we actually call this an infinite solution. So instead of just having that one point, we say there's an infinite amount of points because our lines keep going on forever and they'll keep touching each other everywhere. So we're going to have an infinite amount of solutions. So when you have the exact same line, when you solve them out, if both equations are exactly the same, then your final answer is going to be infinite solutions. Okay? Let's look at one last example 4. And I'm actually going to let you try and do this one on your own. So go ahead and pause the video real quick. Try to do example 4 on your own. And then you can unpause it and check your work with me. All right, y'all. So hopefully you got these two lines graphed. And when you graph them, you're probably like, Mr. Arbone, there's no solution here. They never cross. So something you should notice, both of these two lines have the exact same slope. They both have a slope of negative 2/3. So when two lines are parallel, so not perfectly the same line, but they're two parallel lines, they're actually never going to cross because that's what we know is the definition of parallel lines. They never touch each other. So if they're never going to cross, then instead of having infinite solutions, they'll have no solution. So kind of the opposite to our infinite solutions, our no solution, is when we have two lines that don't cross at all. Okay, so now that we're done, y'all, we have our standard one where we just have standard lines. You graph both lines, find that point of intersection, pretty straightforward. Make sure you write as an ordered pair. if either of the two equations are not solved for slope-intercept form, you need to solve them for slope-intercept form by getting them to y equals. And then if you have the exact same equation, then when you graph it, you're going to see they touch everywhere. So that will be your infinite solutions answer. And if they have the same slope but different y-intercepts, which makes them just parallel, then they'll have no solutions at all because they'll never touch. All right, that should be it, y'all.